So we're specifically going to look at these 4 problems right here. Okay, so I want you to look at number 5. Okay, Brooks, could you describe to me what this graph looks like?
So you start at +1 on the x-axis, like it's like this and this. You start 1 above 0.
Okay.
Then, since it's negative x, it goes down. So then it goes down, and then it's
okay. So this guy is telling us that we have a reflection, and this guy is telling us that we have a shift up 1. Okay, we know that. But what I want to do is I want to find. It's cool. I want to find the zeros. What am I asking for if I'm asking you to find the zeros?
The origin. The first one.
Okay, when we plug in, we get 0. Okay, and I just changed one word from Allison's description. Okay, when I'm asking you for the zeros, I'm asking you for when does this equal 0? Okay, so when I say, hey, find the zeros, I'm asking you to put a 0 in for y. How are we gonna solve this? Henry? How do you know that? Okay. Okay, so Henry's using some guessing and tricking, right? So you're not wrong, Henry, but like, what if that was like another number? Okay, what we can do is we can say, all right, if I factor out a -1, then left over I have x squared minus 1. Ooh, x squared minus 1. That's special. Why is that special? I want you to think your chapter 7 days.
We're in chapter 8, buddy.
It's only chapter 4.
No, we're not.
Okay. X squared minus 1 is a difference of squares where we can factor to a plus b times a minus b. And if I have a product that equals 0, then I know that x plus 1 equals 0 and x minus 1 equals 0. Now, Brooke said that this parabola is shifted up 1 and opens down. So what do you think this 1 and -1 mean on the graph?
They intersect.
They intersect what? The x-intercepts. That's what we're finding. The x-intercepts. You are there. You just kind of describe it. Okay, that's fine. The tip of your tongue. Okay. Zeros are just like, hey, let's find the x-intercepts. Okay. So without having to text somebody underneath the table, let's do this for number 6.
I'm not.
Hi, bro.
Okay. So I want to find the zeros for number 6. So I'm going to put 0 in for y. What would be a good thing to do over on the right side?
Simplify.
Nope. Of? -4. Let's get that negative out. So if our GCF is -4, x squared minus 4, right? Yeah.
Yeah.
So what is x squared minus 4 factor to? X plus 2 and x minus. So this graph that is shifted up 16 is reflected and super skinny, intersects the x-axis when x equals 2 and x equals negative 2. Fabulous that we have just one more piece of information to help us.
Yes, you could say so.
Hillary is really excited about it. I can tell her faces. It wasn't her phone. And honestly, you have no room to talk.
What? Never on my phone.
No, but the disruptions sometimes come from Mr. Brooks. Okay, now we'll do number 8 and then we'll call it a day for notes. So negative 9x squared plus 1. Okay, so I know that there's like a negative 9 in front of our x squared, but let's go ahead and just factor out the negative 1 so that we have 9x squared minus 1 left over, because that's okay, right? Is 9 a perfect square? Yeah, it is. So when I have negative 1 times 9x squared minus 1, Noah, what does 9x squared minus 1 factor out to? Nope. There we go, 3x. Okay. And since it's a difference of squares, I'll help you out there. 3x plus 1, 3x minus 1. Dial it in, buddy. Dial it in. Okay. So if I set these factors equal to 0, then we are getting negative 1/3 and positive 1/3. Okay, so we're intersecting the x-axis close to the origin. Okay, we have a super skinny parabola that's upside down and shifted up 1. So we're looking at the 9 right here. Yeah. Okay. What? Give me a moment.